So between now and Friday, I will try to find that video, since I couldn't get a video of the simplifying rationals and what we did last class. I'll try to get that up and links to the different pieces in Canvas, because I need that. Okay. But did you have some questions? We can answer questions. So did you have any specific questions that you wanted to look at?
I got through it. I just, wanted to review how you did it, because some of the ones I was a little shaky on, and I, was going back and forth with help on the internet and stuff, so, I mean, I got through it though.
Okay.
Yeah, I just wanted to review what you had showed us in class, kind of.
Right. So there's so many things I showed in class, it's really hard to...
Yeah, I mean, at one point, like I said, before the final or whatever. Hopefully.
So one of the things that I did want to point out was, obviously you folks know that things like, if you have a number over another number, or like say you have 24a squared b over 16ab to the fourth, that you can, and we sort of did stuff like this earlier, a couple chapters ago. 24 is really 2 times 12, 12 is 2 times 6, 6 is 2 times 3. So taking the leaves here, we have 2 times 2 times 2 times 3 times a times b. And then 16 is 2 times 2, 4, 8, 16, a, and then 4 b's. So then you could, remember 2 over 2 is still the form of 1. So these all sort of, when folks kind of think of as just cancel each other out, I guess you can sort of think of, they just form 1s. And what you're left with is an 3a on top, and 2, and then 3b's, 2b squared on the bottom. Right? That's the basic simplifying. But then there's also, if I have things like this, like x minus 2 and x plus 3 over x plus 3 and x plus 2, then again you have things being multiplied on top and things being multiplied on bottom. These two will also make a form 1. X plus 3 over x plus 3 is just another form 1. Those they just cancel out. So then you're left with x minus 2 over x plus 2. And we talked about how these x's cannot cancel out because there's a plus sign. Anytime you have a plus or minus sign in there, it's not just things being multiplied on top and bottom. Then all of a sudden you can't cancel stuff out. Right? If I had x minus 2 on the bottom, then that is being multiplied. Then I could cancel that out. But this is one whole piece together. You can't separate it into x and negative 2. It's not x times negative 2. It's x minus 2.
So do you just leave it alone?
Yeah, you just leave it alone.
Oh.
You might have also had some weird ones where it's like negative. I hope I didn't give you any of these. I gave you any of these. Stuff like that. Was there anything like that in there, Eric?
Just like that? Yeah, what's that? It's just it's just 1, right? Because you can just flip it or something. Yeah, there was something like that, right?
This is the same as x minus 1 times negative.
There was a few in the beginning that were similar to this. Yeah.
Negative, because you want the x to be positive. So I could factor a negative 1 out of both of these and get negative 1 plus x. And remember, when these are inside this parentheses, since it's being added, it's the same thing as, I can just switch these around, and I'll get x minus 1. So then those would cancel out. One thing to note there is that the top is 1, the bottom is negative 1, but you can prove that negative in front, so it just becomes negative 1.
Yeah, there was definitely one couple like this.
And anytime you had something just on the nothing on the top, that there's still an invisible 1 on top. So if you have, for example,
Yeah, that's what threw me for a while, is, yeah, when there was nothing on top and I was trying to put the answer in, and then I
Yeah.
finally figured out I have to have a 1 on top.
mm-hmm. We also talked about how, I can take the parentheses away. How dividing by a fraction is the same as multiplying by its reciprocal. Right, so this is the same thing as multiplying by x plus 2 over x plus 3 on the bottom, right? Because dividing, for example, dividing by 4, right? 5 divided by 4 is the same as 5 times 1/4, and it's reciprocal. So here I can multiply, I can take this and multiply by its reciprocal instead. X plus 2 on top, x minus plus 3 on the bottom. And then these guys cancel out. Oh, I left this, maybe I left this as 1. I need to do this to make this work. There we go. So if I did this, then these two cancel out. This is 2 of them, and I only have 1 on top. So then one of these would go away, and that would go away. But there's still an invisible 1 on the top. And x minus 2 on the bottom. Does that sort of make sense for folks? So if you cancel everything out on top, there's still a 1 on top. There's not a 0 on top. Because remember, multiplication always starts with 1. Addition always starts with 0, but multiplication always starts with 1. All right, so I think that's kind of, yeah, I'll get those pieces up for people. They want to, those videos up for last semester. Okay, now we're going to look at finishing up the rational function inverses, the ones we didn't review last class, which was this last one. All right, so let me take a look and see everybody's. Make sure you've got them all. Ryan, can I take a look at yours? Okay, so remember how these work. Is the neat thing about it is the inverse. If I went right 2 up 1, the inverse would go, okay, so my new center, do this a little side. If I go right 2 up 1, my center would be at right to 2, 1. Everyone's good with that part? And what we do then is we put an empty hole at the center, and that's where the dotted lines go through. That's always the first thing you should do. Empty hole at the center, that's where your asymptotes go through, those dotted lines. And then everything else kind of works off of that. They stays out of those lines. So you're going to do that would be 2, 1. Now remember, for the inverse, the x becomes y. They swap, x and y swap. So then your center would be 1, 2, right? Which is right 1, up 2. So then my dot, my center, this center would be at, sorry, here's my thing, would be at 1, 2. So first you do the dotted lines, and then after you do the dotted lines, then you can graph in your, kind of your picture where it goes.
Which is right one over one or left one down one.
Yeah,
Yeah.
right one, up one is kind of where it starts, and then you kind of branch off. Left one, down one, and then kind of branches off. Okay, so we'll go ahead and let's go ahead and go through one here. So like I said, I think you should do the second step first. If you want, you can even do the last step second. So the second step first, how has this been translated? Well, on the inside is it's +3. Is the inside my left, right, or my up, down?
Left, right.
Left, right. So -3 on the inside really means what? Left or right? Natalia, do you remember?
Left.
Left.
E.
Yep.
Yeah.
Left 3. And then on the outside is my up, down. So David, how has it been translated?
Up 2.
Up 2. So that means that my center is -3, right? Left 3, +2, up 2. So I'm going to fill that spot in here. Now I have a couple choices. Either I can say, okay, I'm going to go off of this thing here and say, okay, from -3, 2, I'm going to go, I think maybe we'll leave that alone for now. I think it's better to do the picture first. So then, what we would do is make our picture. I feel like that's a better use of time. So maybe we do step 5 next. I feel like that might be easier for folks, or cleaner. So it was left 3, up 2, was that it?
Mm-hmm.
Left 3,
Yeah.
up 2. That's where your empty circle goes. Your center is your empty circle. That's what the things you can't touch. Cross. So that's where you draw in your asymptotes. Always. And then from there, all right, right one, up one, boom. I can go out this way and go out that way. Back one, down one, there. I can go out this way and go out that way. Seems easy, right? Just do them one at a time. Now, then we want to take a look at our inverse, the third step. Look at the third step here. Step 3, inverse. So my original function was at -3, 2. The inverse center will be 2, -3. Okay, the x and y swap. So how has that been shifted?
Right.
Right?
Right 2.
Yeah, right 2. And then what?
Down 3.
Down 3. Perfect. So then I go back to my step 5. And I put in I graph in my other one, which is, it's a little bit easier when they're not both on there. But you said left 2,
Right.
right 2, down 3. Okay, so right 2, down 3, that's where my new empty circle goes. This is the line I can't touch. See the other line I can't touch? All right, so is this making more sense? Are people remembering this from last class? And then your point that on the graph, out this way, back that way, on the graph, out this way, back that way. Okay, so then we got to backfill all the tables here. So from this graph, my points, let's see, my points, let me go back a couple. So from this graph, I could grab the points, we'll go with the last one. All right, here's my last graph. See the other points on the spot are, what is this, 3, -2. I'm going to fill in this table here. Three, -2. The first one was 2, -3. And then the last one, if I look at it, will be -1, -4.
Yeah.
1, -4.
She's just adding one to both numbers and then subtracting one to both numbers to find out.
Yes.
Yeah.
Right, so like Eric was saying, to find these ones, you can just take the original one, 2, -3, you can add 1 to both of them. So 2 + 1 is 3, -3 + 1 is -2. And you can subtract 1 from both of them. So 2 - 1 is 1, -3 - 1 is -4. You could do it that way as well. And then take a look at the domain. What can x not be? X can't be 2, y can't be -3. X can't be 2, y can't be -3. So then my horizontal asymptotes, the across one, happens at -3, right? Does everyone agree with me? My horizontal asymptote happens at -3. What is it? What is -3? Well, is my y or my x -3? Here at the center. My y is, so y equals -3. Oops. Y equals -3 is the horizontal asymptote, the line it can't touch. And then my vertical must be x equals 2, because if x can't be 2, line it can't touch is x equals 2. Okay, so then we're going to go back to the first one, this guy here, the original function, and say, okay, what are the other points? It's -2, 3, -4, 1. Fill those in. -2, 3, -4, 1. This came from -3, 2. And then my domain, let's see, x can be everything. X can't be -3. X can't be -3. And y can't be 2. Y can't be 2. So then, if you look at the horizontal asymptotes, that happens at y equals 2. Vertical one happens at x equals -3. Right, these have to match up. If y can't be 2, then y equals 2 is that line it can't touch. All right, good. So let's take a look at our where we left off last class, which was at variation. So this is the one we're looking at. That handout. Everybody grab it, pull it out. And remember, there's 2 types of variation. There is direct and how do you know? It will say varies directly or something like that, or is directly proportional. It'll use those sorts of words. It'll have the word direct in it. And that, we're not going to use this one here, we're not going to use the square one, we're only going to talk about the one where it's linear. Y equals kx. It's a line. It's actually even easier than a line because there is no b. Your b is 0. So all you have is just the slope, which is the same thing as k. K is our slope. So all you have to do is find k, and you got your function. Y equals 3x, y equals negative 2x, whatever it is. So here, and as x increases, y increases. The other one is inverse variation. It varies inversely. How do you know it's inverse variation? It will say inverse variation, or it'll say varies inversely, or inversely proportional. It will have inverse in there somewhere, and the word either variation or varies or proportional. This one, and again, we're not going to use this guy here. We're just going to use this one here. Y equals k over x. So, all you need to do is identify what your x and your y are. I recommend having your y be the one that you're trying to find, the one you don't know. Then, so you're given two scenarios. Sort of like, after 2 hours, there is 4,500 gallons in the tank. How many hours will it take for there to be no water in the tank? So how many hours, that's your y. And then make x your gallons in the tank. Does that sort of make sense? So then the first one, you're given a point. Well, I'll go through them with you. It's easier if I do that. So we'll take a look at the examples. So here's the example of we'll do the inverse variation first. Just going to review it with you. We did it already. So here, what is the water temperature? So find the two things that vary. First, find the two things that vary in the problem. In this case, it's going to be water temperature and the depth in meters. And since I have this what is the water temperature, I'm going to make water temperature my y. So water temperature, here's another water temperature. Those are my y's. And I'm going to make 5,000 meters, I'm going to make those my x's. I'll make this one red so you can see the difference. And what you'll see is depth of 1,000 meters goes with water temperature of 4.4. Those are kind of one group. They go together, right? At 1,000 meters, water temperature is 4.4 Celsius.